Hello people, my name is Zorz. I work for Internet Society. I come from Slovenia. That's quite far away from here. And thank you for inviting me again. I think my last CEFNOG was CEFNOG 2 in Swaziland. It was excellent, and I'm glad I made it to CEFNOG 3. All right. So before Net64 check tool was mentioned, and since this is the IPv6 session, but I will not talk about Net64 check tool. We will talk about Net64 check tool tomorrow when there is the ION meeting for the whole day. I will have the presentation about how that tool works and how useful it can be if you want to test how your content is seen from various environments. Today, I want to do a talk that is a premiere talk. This is the first time I'm giving this speech. So if it's not perfect, please excuse me. So over a year ago, we started working on a document that was a result of me traveling around the world talking to operators about deployment of IPv6. What I usually do is I talk to people and try to identify what kind of issues they have with deploying IPv6, and when I see the pattern coming together that is a common problem, we try to address that. So if we go a little bit in the past, probably some of you may recognize the RIPE 554 document. That was the requirements for IPv6 in ICT equipment. That document is now translated into more than 17 languages around the world. People just took it and translated it. And this is a document about how you should require IPv6 when you are buying equipment in the procurement process. This is used all around the world, but we saw that there is a problem because people don't know how to order the equipment when they buy one. Then the next problem that we identified was when operators said, okay, we enabled IPv6, but we don't want to enable it for our end users because our help desk would just burn down in flame. So to fix this problem, we wrote RIPE 631 that took us well over a year and a great group of co-authors, and it also got the consensus in RIPE BCOP task force and in RIPE IPv6 working group. And this is all about IPv6 troubleshooting for residential ISP help desks. So now with this IPv6 speed bump removed from the operators, because now they have the procedure how to troubleshoot IPv6, we figured out that the next common problem that I keep hearing around the world is when people go, okay, now we will deploy IPv6 to the end users, but what is the size of the prefix that we should give to users, and how should we delegate it? How should we assign it? Statically or dynamically? So who in this room is now deploying IPv6 to the end users? Hands up. Who is thinking about doing it in the next year or two? Okay. So how would you decide what is the size of the prefix delegation? You'd probably start asking questions, right? And I would probably get annoyed because everybody asked me the same question, and I need to go over same thing all over and over and over again. So we decided to just put it down in the document. These are the authors of the document. I think few of them are in this room. At least is Kevin here and Andrew. Andrew Alston is also one of the co-authors of this document, because some of things that are an advice here to the operators, he experienced firsthand on his own skin, and maybe later on he will add some of his insights, because here in the document it's anonymized. It's not specifically said who did that. But as you see, there are quite good people, quite good IPv6 experts and operators from around the world that contributed their practical knowledge. So, first about the status, work is done. I'm more than happy to announce that on 4th of September, that's 2 days ago, that's 1 day before my birthday, and that was a great birthday present. The document reached consensus in a RIPE IPv6 working group. The chairs declared the consensus, and I was a happy panda. So, as you can see, the first draft was done on 27th of March. That's half a year ago, and we needed quite a lot of time to put the first draft together because it grew to 11 pages, from 4 pages to 11 pages. It was 7 interactions, 7 editorial cycles. There was lots of feedback from the community, and after the 7th editorial cycle, after the 7th draft, we reached the consensus. So, what is this all about? I thought of putting the table of content in. As you can see, at the beginning we have the executive summary. That is the latest addition because paper document grew so big that actually everybody knows executive guys, and we all know how also technical paper works. If it's longer than 2 pages, nobody will read it. So we put the executive summary at the beginning. And just out of fun, I had an idea to call it a conclusion and put it at the beginning of the document. But then we decided to call it the executive summary. Then we have basically what is a BCOP, that's a very short one. We have introduction and incentives. And then we have number 4 is the size of end-user prefix assignment. Is it /48, /56, or something else? And there in this section we discuss in very pragmatic and practical terms why different options are a viable solution or not. Then we go into how you number the WAN link, how you assign the resources for the LAN behind the CPE, and then we go into the discussion in number 5 about end-user IPv6 prefix assignment, persistent or not persistent. And here is where Andrew's experience came to help. And then we have acknowledgements, and let's little bit see what is written in here. That's just executive summary. It basically says IPv6 is not the same as IPv4. In IPv6 you assign a short prefix to each end customer site, so they are able to have as many subnets as they need. It is strongly discouraged to assign prefixes longer than /56. If you want a simple addressing plan, /48 for each end customer. In order to facilitate troubleshooting and to have future-proof network, you should consider numbering the WAN links using global unique addresses. Not persistent prefixes are considered harmful. That means if you assign them dynamically from the pool on your BRS or something like this, you will get into trouble. Believe me, you will get into trouble. Yeah, so assigning persistent prefixes is a safer and simpler approach. There was people saying that, oh no, we should not make it static, we should go dynamic because this is the future and this is how things should be done. And I agree. But that is the discussion that needs to be taken at the ITF. That's the venue where the future stuff is being thought and figured out. Here, this is the best current operational practice. And currently, with the development state of IPv6 and CPEs, this is the advice that you need to take and build it in this way if you don't want to get into trouble. We all know that if this changes, this advice will also change. If the development of CPEs goes forward, and it's described also in the document, this advice will change. But currently, as we stand, this is the thing that you should be doing. Okay, BCOP and why. BCOP is basically the document that explains the best current operational practice and should be coming from the operators and written by operators for operators. And it's usually coming out of the real world experience. So why did we do this? Because lack of compliance with the new standards, such as HomeNet, this is currently becoming a big problem. Okay, so size of end customer prefix. Is it /48, /56 or something else? Change your mind, this is not IPv4, right? In IPv4 we count IP addresses. In IPv6 we have subnets that has different meanings and different usage types. For example, /64 is the smallest prefix that you should put on a layer 3 interface where there are hosts. You don't want to count all the hosts. So usually when I'm doing IPv6 training, I ask the students, do you know how many hosts you can fit in 1/64? And usually people start guessing the huge numbers, and there is a very, very simple answer. All of them. Because MAC address is 48-bit, and if you have 64 bits, you can fit all of them. So stop counting addresses, right? And do not use /64 as the end user prefix delegation. It's just plain wrong in so many levels. For example, even today, if you put on your network Linksys CPE, it creates a guest wireless and a LAN. That immediately means 2 networks. And with /64 assigned, one of them will be unnumbered and completely useless. So even today, if you start assigning /64 to your customers, you're not doing yourself a favor, nor a customer a favor, because there will be a moment in a very short future where you will have to go and redo everything you did. So do it right from the very start. So numbering the one link, you need to connect CPE somehow to the provider's core, and there are several options. One is /64 out of the end customer prefix. One is /64 out of a dedicated pool of addresses that you keep on your BRS or whatever you use for your aggregation point. You can do unnumbered, and one of the options is ULA. So /64 from a customer prefix. For example, you assign a /56 or /48 to the customer, and you use the first /64 to number the one link. This is somehow cool, and it's very easy because then you don't have to keep separate things for separate recordings, which user has which prefix on the one in conjunction with prefix delegation that you gave it for the network. But some CPEs do not support it, right? Some CPEs go crazy if you try to do that. On the other hand, it's being required by RFC 7084. That's the basic requirements for IPv6 CPEs. So if you want to go this path, be very careful. Be very careful, because some CPEs may do crazy things. This is the most common one, /64 from a dedicated pool. That is usually the most common one, because CPE performs the router discovery. If you use PPPoE or something like this, if this is a host that is connecting to your network, like a Windows machine or Linux machine or something like this, it will just get the /64. Your machine will get the IPv6 address, and you will be able to to use this connectivity to the outer world, and the whole thing will just work on IPv6. If it's a router, then it will number the one link and then do the DHCP prefix discovery, prefix delegation discovery, and you will get the prefix delegation. But in both scenarios, or you are connecting a router or you're connecting the end host, this scenario will work. Then there was a discussion, should we use /126/127/112, because this is a point-to-point link where there are no hosts usually on it. Again, same thing as before. Today, this is not a very safe option to go, because not all hardware supports it, and /64 is just plain bulletproof and future-proof. Unnumbered. Some people want to go unnumbered because they claim, oh, it's safer, it's security, it's I don't know what. Okay, you could use link local addresses. But this doesn't work for the devices that can't request prefix delegation. For example, if you would do the PPPoE from your Windows machine and your provider would use unnumbered, you will not get IPv6 address. And this is not very nice, is it? Right? You can't talk to IPv6 internet without the address. So no global address. No global address means no traffic, right? It complicates the troubleshooting, despite the fact that the router that will get the prefix delegation will probably number the loopback, and this can be used for troubleshooting. But again, why complicating your life? We have enough addresses. Use /64 from a special pool and be done with it. Okay, ULA, strongly discouraged. Forget about your IPv4 knowledge. Don't do it. ULA is just not the way to go and number the one links. Of course, you will break PathMTU discovery. ULA source address will not traverse the filters outside your network, and IPv6 connection will break if PathMTU is not the same. Because when PathMTU discovery process starts, the CPE will start sending packets to the outer world out of its IPv6 ULA address, and that should not go anywhere. So, one link summary, use /64. That's the basic rule. Prefix assignment options. Now, please at least align the delegated prefix with a nibble boundary. It will be much easier for you for your routing and for your logging and for your statistics and everything. It will be much easier if you do on a nibble boundary. And a single customer network is /64. That means you should give your users the option to create more than one network. Now, RIR policies, majority of them allow up to /48. I don't know, Alan, is that also the case here in Afrinic? Yeah, Alan is nodding. Thank you. So you can easily decide and give your end user a /48, and it doesn't matter if that's a residential user or a business user, and then you can go back to Afrinic and say, hey, I assigned /48 to all my users, I ran out of space. That will be quite unlikely, but if that happens, Afrinic will understand and say, okay, we understand /48 is the rule, and please continue doing the good work. Okay, some people does /48 for business and /56 for residential. There is no technical reason to do that. Majority of cases when I heard that, the rationale came from marketing sales department. Because they wanted to make a distinction between a residential connectivity and business connectivity. Because in IPv4, residential guy can just have a dynamic IPv4 address, and business people could have static or a prefix in IPv4. So they want to make the same distinction in IPv6. It doesn't make any sense, but apparently it sounds good on a glossy papers. So, you know, if they want it, then okay, you can have it, no worries. There is no, technically it's not wrong. It may complicate a little bit for advanced home users because they cannot use all the 4 digits in their addressing plan. Or if some people already have the planning, then they cannot just simply change. But yeah, it's up to you. It's not technically wrong, but a little bit more complicated for some people. Alternatively, what I heard from people was that people reserve /48 and actually assign /56 if there is if user calls the help desk and starts complaining about it, they just change the assignment and they're done. This is also one good thing to consider if you decide for this option. As we said, /48 for everybody. This is the most practical and pragmatic way of doing things. As again, RIR allows it, and it's taking it into the account when you're doing your planning. It's single flat provisioning system, and you can do also if you already have the mapping done. And if you played with, I don't know, Hurricane Electric back in time with tunnels, you receive the /48, and you just map the existing mapping into the new prefix, and you're done. Less than /56, not recommended. Really, really don't do it. You have enough addresses. Try not to drag bad habits from IPv4 into IPv6. It's a brave new world, right? Start from scratch, start fresh. Technically there is no reason for that. If you need more space, ask your RIR for more space, but never assign less than /56. There is one exception for mobile phones. Operators usually, when you connect your mobile phone to IPv6 APN, by default, every phone gets /56. So this case is outside the scope of this document. And if you get /64 for one device, that's kind of cool, is it? But LTE modem still requires /56 or /48. So 48 for everyone. Okay, persistent or non-persistent. Persistent typically means that AAA or custom provisioning system, you put in the prefixes that are tied to a username or whatever authentication mechanism you're using for your network. That means that every time this user will reconnect to the network, he will get the same prefix assigned, and his devices will operate out of the same prefix in your internal network. Non-persistent means a big pool in each termination point, and then when people connect, they get dynamically IPv6 prefixes out of that pool, and basically when they reconnect, they can get a completely different prefix from before. Yes, non-persistent is easier, and operators are quite keen to cut the corners. I know, I've been one for 20 years. You know, why complicate if things can be done easily? You know, you put your pool of IPv6 addresses on the BNG, and then you let them assign easily. It's easily done. But this comes from IPv4 practice. And in IPv4 we have NAT. In IPv6, well, there is NAT, but don't use NAT. In IPv6, if you renumber the network, that doesn't mean just renumbering the outside-facing interface of a CPE. That means renumbering the whole interface, the whole network that is behind the CPE, and that's not a simple task, as we learned in practice. It's easier for aggregation, but it will bite your back. It will bite you. If today, if you go into it, until the CPEs don't have all the mechanisms in place that would prevent the issues with this, don't do it. Non-persistent is harmful. So let me go through a little story, and maybe Andrew will at the end add a little bit to it from his practice. In case of power failure, CPE hangs. That's common everywhere. Not just in your continent, that's common in Europe, that's common everywhere. CPEs are electricity eaters, and they need electricity to live. And if electricity is gone, they die, and they come back when electricity is back. And when CPE comes back, it connects, asks for new prefix delegation, and gets the new prefix, completely different from before. What happens is that the CPE does not remember which prefix was used previously, before there was a power cycle or freeze or whatever. And it doesn't send the RA packet with lifetime 0 to deprecate the previous prefix on the network. So what happens is you have a laptop, you're connected over wireless, and all of a sudden you have old IPv6 address from the old prefix that the route was removed because CPE rebooted, and you have a new IPv6 address on your network, on your Wi-Fi device. And according to Murphy's Law, your machine will still use the old IPv6 address as a source for the communication. And then what happens is that you go to, for example, Google or any other big search engine. They use IPv6. They prefer IPv6. And what happens is that you send a SYN packet, and they send you back the SYN ACK packet on IPv6. But that SYN ACK packet never reaches you because there is no route pointing from the operator back to your CPE, because that's an old prefix. And there is no way that you would send them back the ACK packet. But they measure the brokenness. They measure the brokenness. If they send the SYN ACK packet and do not receive the ACK packet, they mark your whole AS number as IPv6 broken. And they stop serving you quad A's. They stop serving you IPv6 traffic. And this is happening more and more and more and more and more. You could go this way if all the CPEs that are connected and your customers have would have this mechanism, like, for example, I think Fritzbox implemented it, that it has a battery inside and it actually remembers the last prefix that was delegated, and then when it comes back and gets different prefix, it starts sending RA packets like crazy to deprecate everything before handing out the new prefixes. But this is not the case today. So if you don't want to get into a huge mess, then just don't go dynamic. In the future, yes, I agree. We should fix that. But now, practically, not so much. Okay, so the best choice, persistent or non-persistent, today is persistent. Or at least if you don't have other option, put a pool of IPv6 prefix addresses on your BNG and set up a lifetime on DHCP to eternity, basically, to 300 years. And make sure that people get the same prefix all the time. If you can't put them in a AAA system, in a radius or something like this. This also avoids having the logging systems, because at any point in time you know who had this prefix and who had these addresses, because it's just that simple. You just go in and have a look which addresses are from which user, because they don't change. So you can do that. However, the one link can be non-persistent. That can be dynamic. That works with dynamic /64s, but don't make prefix delegations dynamic. Yeah, that was a picture that was from Budapest. That was lots of co-authors of this document are here. This was the meeting, the editorial meeting for draft version 2. So as you can see, this document was done in quite a nice and relaxed environment, but a lot of experience was poured into it. So if you want to download the draft that got the consensus, here is the link. I hope that the slides will be published. Now, RIPE NCC is in the process of editing the document, translating Younglish into English, and fixing the grammar errors. And they will assign it an official RIPE document number, and when we will have an official document number, we will publish it, of course, and send it to your mailing list. But until then, the content will not change, because we got the consensus from the community that this is the document and this is it. And if there are any questions. Andrew. I'm in such good position now because he's a co-author, he can't bash me.
No, I just wanted to comment a little bit on what you said about the dynamic prefixes versus the non-dynamic prefixes. Firstly, I would say that setting a lifetime of forever on a DHCP is still not ideal for many, many reasons. But look, we tried the dynamic approach, and it failed. It failed dismally. And it's not a case of the fact that it needs to go back to the IETF. It's a case of the fact that the CPE vendors need to start following the current RFCs that have already come out through the IETF, because the standards are already there. It's just that the amount of CPE breakage out there in V6 CPEs is quite horrific. We went dynamic, it didn't work well. We went static, and today we've got 23,000 V6 static assignments made. They're all in the Afrinic database, which makes it really easy to look up. And if I look at that particular network in Zimbabwe, we are currently doing 40% of the total traffic into that network on V6. So it works. But when we tried it on dynamic, that was sitting at about 5 or 6%. It just didn't work. So, and I must just also extend my thanks to Jan and Sander Stefan and Anthony Somerset, who sat through me with many long nights while trying to figure out all the breakage that was there. But it was worth doing, but please stick with the static assignments. It's not worth doing the dynamic.
Thank you.
Thank you. Amrish.
Amrish Afrinic. I was wondering if this document could be useful to push it to the ITF as a BCP, make it available to a larger public. Do you think that's useful?
Maybe. Do you want to write a draft?
No. I'll let Andrew do it. I haven't seen Andrew at the ITF yet, so I want to see that.
Yeah.
Another question maybe, so I understood you are actually recommending static /48s and assignments. So, but I'm wondering what people were doing before that, and was there not some sort of best practices earlier than that?
Probably your imagination is not big enough to think of what people have been doing. People did a lot of things. People assigned even /112 as a prefix delegation because they said, oh, that's the same number of addresses as in IPv4. I was like, oh my God, are you serious? Of course, things didn't work, and you know, all these people then, when things doesn't work, and they hear from other people that things are working, then they start asking questions, and then after some painful cycles of being in the dark and trying different approaches, then eventually they come to a solution that works, that is described here. So that's why we thought just to put this in the document and let everybody read it and just save everybody's time while they are sailing in the dark without the light. But yeah, I don't know. Maybe about the ITF BCP. Maybe we have to think about it. Maybe Afrinik will want to also write something about like this or any other RIR region. But that's not up to me, right? That's probably up to somebody that actually lives in the region. I'm from far north. Yeah.
Jan, I have a question for you.
Yeah.
And maybe the other authors. I was expecting to see something on reverse DNS.
Yes. The problem is that this document grew from 4 pages to 11 pages. And there was lots of ideas from the community coming, oh, you should put also this, and you should put also that, and you should go into the more specific and more details of this and that and that. And then my question was very simple. Do you want 300 pages document? And the answer was no. So we tried to stick to 11 pages. But I have a list of topics that could potentially be the new BCOP document. Because BCOP documents, if they are long, they are basically useless. So maybe we should start writing a BCOP document on the reverse DNS and implications of it in according to this document.
Okay, good.
Any volunteers? No? Everybody, now all of a sudden everybody's reading email. Yeah, right.
All right, thank you very much, Jan.
Thank you very much.